Section 3.1, Exponents and Order of Operations. Start with the basic concept of what we mean by a natural number exponent. So here what we see is if we have 3 times 3 times 3 times 3, this can be written in a shorthand as 3 raised to the 4th power. We call the 3 the base, and the 4 is the exponent. It is written to the right of the number and above, at a higher level than the number, and in a smaller font than the base. All right? And that signifies the number of factors of 3 that are present. So, for example, 5 to the 2nd, the base is 5, the exponent is 2. And what that really means is 5 times 5. 10 to the 5th, base is 10, exponent is 5, and that really means 10 times 10 times 10 times 10 times 10. Why don't you try the other 3 on your own? Two sevenths to the 3rd power, the base is the entire fraction 2 sevenths, and the exponent is 3. And so that means 2 sevenths times 2 sevenths times 2 sevenths. 1 to the 12th power, the base is 1, the exponent is 12. And so what this means is 1 times 1, and there's a whole bunch of 1s here. In fact, there would be 12 factors of 1. And finally, 15 to the 1st power, the base is 15, and the exponent is 1. And what this means is there's a single factor of 15. And so that would be simply 15. So then, how would we write 4 times 4 times 4 times 4 times 4 as an exponential expression? Since there are 5 factors of 4, the base is 4, the exponent is 5. And so this would be 4 to the 5th power. Similarly, for the second example, y times y times y times y times y times y times y, there are 7 factors of y, and this can be written as y to the 7th power. So then how would we evaluate an exponential expression? Well, if we remember what the exponent means, then it simply becomes a repeated multiplication. So for example, 2 to the 5th power means the base of 2, 5 factors of 2. And now just simply go through the multiplication. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Why don't you try these other 3? Now would be a good time to pause. Nine to the 1st power means we have a single factor of 9, and this can be written as 9. 10 to the 4th power means 10 times 10 times 10 times 10. 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000. 3 sevenths to the 2nd power means 3 sevenths times 3 sevenths. Multiplying the fractions gives us 3 times 3 over 7 times 7 or 9/49. Now, we want to take this in a different direction. Here we are asked to write 64 as an exponential with base 2. So the idea here is 64 can be written as 2 to what power? How many factors of 2 would be needed to give us 64? Well, let's see. 64 is 2 times 32. The 32 is 2 times 16. The 16 is 2 times 8. The 8 is 2 times 4. And the 4 is 2 times 2. And so let's see, we have 1, 2, 3, 4, 5, 6 factors of 2. And so then we would have 64 is 2 to the 6th power. Why don't you try the other one on your own? Write 36 as an exponential with base 6. All right, so we want 36 to be 6 to the what power? Well, 36 is 6 times 6. We don't need to go all the way down to prime factorization because we were trying to write it as an exponential with the base 6. So since there are two factors of 6 that give us 36, 36 is 6 to the 2nd power. The standard order of operations tells us that when we are evaluating arithmetic expressions, we use the following order of operations. First, we perform all calculations within grouping symbols, or above and below the fraction bar, and within the grouping symbols or outside of the grouping symbols, we follow the continuing order that we evaluate all exponential expressions. Then we do all multiplication and division as they appear from left to right. Then we do all addition and subtraction as they appear from left to right. So let's get some practice using the order of operations. Here our instruction is evaluate, which means we want the numerical value of this expression, and we will follow the standard order of operations. Looking at the first exercise, we have 6 times 7 subtract 14. There are no grouping symbols, so we would continue on to the next step, which says we would evaluate exponents. Well, there are no exponents, so now we would take care of any multiplications and divisions we see from left to right. I see a multiplication, so I will simplify the 6 times 7 as 42 minus 14. And now I'm down to the single operation of subtraction, and so then this would yield 42 subtract 14 yields 28. So 6 times 7 subtract 14 is equivalent to 28. Quantity 1 plus 4 raised to the 3rd power, we have a grouping symbol, so we would evaluate within the grouping symbol first. There's only one operation within the grouping, so we would just complete that operation. So this would give us 5 to the 3rd power, and then continuing, this means 5 times 5 times 5, right? Because 5 cubed has a base of 5, exponent of 3. So now, following through on the multiplication, 5 times 5 is 25. 25 times 5 is 125. Why don't you try these other two on your own? In this third example, we have a grouping symbol. The fraction bar is a grouping symbol. And so what we would do is evaluate above and below separately before going through the division. All right, so we would evaluate the 3 plus 1 in the numerator and the 3 minus 1 in the denominator separately. So this would give us 5 subtract 4 over 2. Now we have a subtraction and a division. Division takes precedence over the subtraction. 4 over 2 is 2. And so we have 5 minus 2, which simplifies as 3. Finally, we have 12 divided by 3 times 4. Now remember, in the order of operations, well, we have no grouping symbols here and we have no exponentials, so we would go straight to the multiplication and division. But remember, multiplication and division are on the same level, and we evaluate them as we see them from left to right. So the first operation would be 12 divided by 3, which is 4, and 4 times 4 is 16. Let's get some more practice with translating from words to symbols. So we have 7 cubed minus 8. Cubed is a phrase that means raised to the third power. So 7 cubed minus 8 would be written as 7 exponent 3 subtract 8. Another phrase that we don't see here but you might see somewhere else is if we were to see squared. That phrase means raised to the second power. "40 divided by the sum of 8 and 2. Sum tells us an addition, so we need to add 8 and 2. We need to divide 40 by that sum. So here's the division. I'll use the fraction bar. The sum of 8 and 2, 40 divided by that sum. The difference between 2 raised to the 5th power and 9. Difference tells us we need a subtraction. 2 raised to the 5th. We're finding the difference between 2 raised to the 5th. Hey, that's an exponential. And 9. Let's finish the section with an application. Suppose that a savings account containing $600 will double in value every 9 years. How much money will be in the account after 45 years? Well, so if the money will be in the account 45 years and it's going to double every 9, we would take our initial number, $600, and it's going to double. Well, that means multiply by 2. But how many 2's? Well, in a sense, there's going to be 5 cycles here. 45 years, and it's going to double every 9 years. 45 over 9 gives 5 doublings. So this is 600 being multiplied by 2 to the 5th power. And so we would have 600 times 2 to the 5th is 32. And 600 multiplied by 32. Oh, let's go through that multiplication here. Let's see. 32, multiply that by 600. I can immediately drop the 2 zeros. 2 times 6 is 12, carrying the 1. 3 times 6 is 18, plus 1 is 19. So, according to the problem, there would be $19,200 in the account after 45 years.